All right, so last time we did part of section 2.2, okay, finding complete graphs. We're going to finish up 2.2 today. Okay, so the first problem we're going to look at has to do with a company that's producing a product, and they talk about having two different kinds of costs, fixed costs and variable costs. Okay, a fixed cost is a cost that always stays the same. It never changes, regardless of how much product you produce. Okay? A variable cost, that's a cost that changes. Okay? And it depends on, say, how many of the item you make. Right? So if you had, say, a person that earned a salary of $50,000 a year to work, making these parts, they probably make the same, assuming they don't get, commission on how many parts they make. They make the same amount of money regardless if they produce 50,000 parts in a year or 70,000 parts. Okay? They make the same amount of money. But the variable cost, there's a cost associated with making each part. Right? Maybe it's 10 cents a part. So that's what could change, depending on how many parts you make. Okay, so this particular company has a fixed cost of $200,000. Yeah, that could include all the money for the employees, the salaries, things like that. Okay, but there's a variable cost of $1.50 per shirt. Okay, this is the cost for the company to make the shirt. $1.50 for every shirt, but then they're going to sell each shirt for $4. Any question on the setup for the problem? All right, so there's a couple different words that you want to be careful of here. There's cost, there's revenue, and there's profit. Okay, cost is what, say in terms of the t-shirts, that's what it costs the company to make them, $1.50 per shirt. Revenue is how much money they take in per shirt, $4. The profit is, okay, we look at how much money we took in, we look at how much it cost us to make it, and then we subtract. That's the profit. All right? So first thing they want us to do is find an algebraic representation, so we can then graph it, for the cost and the revenue. They're not interested in the profit right now. If you can find cost and revenue, profit would be pretty easy. Okay, let's start with our costs. Okay, what would be an equation here that represents the cost for this company? And we might need a variable depending on how many shirts they make. Marina?
200,000 plus 1.5x.
Okay, so she said 200,000 plus 1.5x. Now what's x?
The number of shirts.
Sure. So number of shirts produced. So the 200,000 never changes. Okay, that's fixed cost. And what would be the equation for our revenue? Okay, not our profit, just the revenue. Oh, Cassie? What would be an equation for our revenue?
It would be 250x.
Yeah, 250. And can you tell me, how would you write that?
2.5x.
Okay, now is that the money that we took in? Or is that something else? So remember, there's a difference between cost, revenue, and profit.
Oh, revenue.
According to our
4x.
book, yeah, 4x. Okay, that's just the way our book breaks it up. If you look at page 87. Okay, so this would just be 4x. Okay, now I want to find a complete graph of these two equations. Okay, so we have 200,000 plus 1.5x. Okay, that's my cost and my revenue for x. Now we have some big numbers there in y1. Okay, if we use our standard window of -10 to 10, is that going to work well? No. Okay. The y-axis are my costs. Okay, so I know that at a minimum, okay, y1 has a y-intercept of 200,000. Okay, so let's set our y max. Let's try maybe like 350,000. Okay, let's try that for now. Because remember, we're going to be having more costs than just 200. 200 is the cost if we don't sell any shirts. But then the cost could go up from there. All right? And our y min. Is it possible for our costs to go negative? No. It's always going to cost us money to make the shirts. Okay. Now, x min is the minimum number of shirts produced. What would be a good minimum number of shirts? Yeah.
0.
0. And x max, well, that's how many shirts we make. We don't know the max. Let's try like 300 shirts. Okay, this might not be the best window. We'll hit graph. We'll take a look. All right. It's hard to see, but the red line, that's the one that has the slope of 4x and should be coming up. It's because we haven't sold nearly enough shirts to even show it. So let's try, instead of 300, let's try 3,000. All right, now we can kind of start to see a little bit of a slope here. Okay, the blue line and red line. Before they almost looked horizontal. Okay, let's try 30,000 shirts. Okay, so there's our costs. There's our revenue. What do you notice about the cost and the revenue? What's starting to kind of happen? Yeah?
They're about to intersect.
Yeah, they're going to intersect. We don't know where. Let's try 300,000 shirts. Okay, so now we can see them intersecting. Okay, and that's a good complete graph. Maybe we didn't have to set x quite that high. Maybe we could have got away with 200,000. But the window we just had is fine. Any question on that? Okay, does anybody know what that's called? Or what's going to happen where the cost and the revenue cross each other? Yeah?
That's where they would break even.
Right, so you're going to break even. That's basically where you've now made enough shirts that your cost and your revenue are the same. After the break-even point, what happens? Yeah?
You make money?
Yeah, you start making money. Right? Okay, and as somebody said earlier, that's called the break-even point. It's the point at which the cost and the revenue are the same. Okay, I think we already kind of answered that for a graph of cost and revenue. Where is that point? It's the intersection. Right? It's where they cross. So now example 2, using the example 1, find the number of shirts that we have to sell to break even. Okay, let's do it algebraically first. Okay, what's the idea of a break-even point? It's where, Michael, it's where what equals what? Just in general terms.
Revenue equals cost?
Exactly. Okay, so algebraically, we have to set cost equal to revenue. So we just need to look up our formulas for cost and for revenue. Okay, so my cost is 200,000 plus 1.5x. And set that equal to my revenue, 4x. Okay, we'll solve it. Andrew, what's my first step to solving that equation?
Subtract 1.5x.
Yep, subtract 1.5x. And 4 minus 1.5x is how much?
2.5x.
Yep, 2.5x. Okay, and then my last step, Justin, to get x by itself. Yep, divide by 2.5 and divide by 2.5. Okay, so we'll do 200,000 divided by 2.5. So that's 80,000 shirts. Any question on doing that algebraically? Okay, now we'll look at it graphically. Graphically, we basically already did most of the work. Just graph your lines and calculate the intersect. Anybody remember how you do an intersect? Can tell me the buttons I need to press? Yep, Andrew.
I think calc.
Second, calc, okay.
And then 5.
Yep, and then 5. Now you pick a point somewhere on the first curve. Pick a point somewhere on the second curve. And the guess doesn't really matter, just controls how long it takes to get the answer. And it tells us that once we sell 80,000 shirts, we will break even. Okay, and the value and the cost and the revenue, what will that actually be? It'll be $320,000 costs, and we'll have $320,000 in revenue. Subtracting them, we get 0. That's the break-even point. Any questions on that? So that was really it for the end of section 2.2. For 2.3, I don't think we're going to need the calculator as much. We're going to focus more on algebraic methods to solve linear basic equations, and then we'll get into quadratics. Specifically, we're going to take a look too at the quadratic formula and how we actually get the quadratic formula. Okay, where does it come from? All the negative b, plus or minus, square root, all that stuff. All right, so first thing we start out, just a basic definition of what an equation is. So an equation's a statement that has an equal sign in it. And then we have an expression on the left of the equal sign and an expression on the right. If our equation in particular uses a variable that we call x, you could say you have an equation in x. All that means is you have an equation where x is the variable that you're using. Okay, and there's a few different kinds of equations. Okay, we'll go through some of these as we go. That's an equation. That's an equation. And that's an equation. Anybody know the names of any of these three types? Those are basically the three types of equations you can have when you're solving. Yep?
So the variable is a conditional?
Exactly. This is called a conditional equation. The reason it's conditional is because there is a certain condition that has to be met to make it true. If you let x be the right number, it will be true. But for any other number, in this case, it will not be true. So it's a conditional equation. How about one of these two? Yep?
5 equals 2 is a contradiction.
Yeah, that's a contradiction. A contradiction is an equation that can't be solved. This would usually be the final step you'd get a number equals a number, and they're not the same. And how about 3 equals 3? Yeah,
Identity.
very good. That's an identity. I think we're going to talk more about identities later on. Okay, an identity is an equation that is always true. No matter what value you pick for the variable, you can never make an identity false. And again, that would normally be the last step in a sequence of steps. All your variables would cancel out, and you'd end up with a number equals a number. So we're going to start by focusing on conditional equations. And to solve a conditional equation means to find the values of x, value or values, that make it true. Generally, as you have an equation and the exponent starts to get higher and higher, you can have more and more solutions. For a linear equation, the exponent on the variable is just a 1. So at most, you can have one solution to a linear equation. If you get into a quadratic, the exponent's 2. You could have 2 solutions at most. Okay, but let's start off with the basic equation. All right, so an identity, we said earlier, that's an equation that is true for all values of the variable. Later on, when we start trig, we'll study some identities in trig. Here's an example of an identity. You have 3x plus 2 on the left, and if you distribute this out, you have 3x plus 2 on the right. You have the same thing on both sides. You'd end up with 2 equals 2 if you start to solve that. Okay, here's a trigonometric identity. Sine squared plus cosine squared always equals the number 1. Okay, you don't have to know that identity yet, but if you try it, take any angle you want, take the sine of it, square it, write that number down. Take the same angle, take the cosine of it, square it, write that number down. If you add them up, you'll always get 1 as the answer. Always. Okay, and the other type of equation we mentioned earlier was a conditional equation. It's true for certain values of x. In this case, when x is 5, if you solve it. Okay, if you want to verify that a number is a solution to an equation, you plug it in and you check it. If you end up with a true statement, then you know your answer is right. If you end up with a false statement, then your answer is wrong. Okay, here's an equation that I'm not sure how many people would know how to solve by hand. It's a cubic. If you could factor it, maybe you could get lucky and try to do something with that. But if you're not sure how to factor this, and we don't know the cubic formula, like the quadratic, we could graph it. Okay, we could do it that way. But in this case, I'm telling you that x equals negative 2 is a solution. I just want you to verify it. Okay, so we just plug it in and see what we get. So negative 2 cubed minus negative 2 plus 6. Checking to see if that does equal 0. Brandon, what's negative 2 cubed? Negative 8. Okay, and Tahina, what's going to happen with the minus negative 2?
It's going to add 2.
Going to add 2. We have a plus 6. Negative 8 plus 2, that's negative 6 plus 6. We get 0 equals 0. So that's correct. That means negative 2 is a solution. What does that tell us graphically? If you were to graph x cubed minus x plus 6, and you looked at the picture, what's going to happen at negative 2? Yeah?
It's going to cross the x-axis.
Right. It's going to cross the x-axis at negative 2. We don't know if that's the only solution, but we know that it's at least one solution. Okay. Any questions on that? All right. So this is a linear equation, okay? Definition of a linear equation. Ax plus b, and I have it equal to 0 in this case. A and b can be any real number you want, except a cannot be 0. Why can't a be 0? If you plug in 0 for a, what ends up happening in that equation? Cassie?
The x value becomes 0.
One more time?
The x value becomes 0, so it'll just be b equals 0.
Yeah, what happens is the linear term cancels out. Okay, so no matter what x is, it's multiplied by 0, so it's not there. So you have b equals 0, that's a constant equation. It's no longer linear. It is a horizontal line, but to be linear, our book says it has to have a slope that's not 0. All right, so this will probably be one of our only problems we do solving a linear equation. Okay, I'm hoping from Algebra 1 everybody knows distributive, combined like terms, all that stuff. All right, so Julia, what's the first thing I would do here?
Do the distributive property.
Okay, and what would that give me?
4x minus 6
Plus,
plus 3x plus 3.
okay, so she did out all the distributive property that she needed to do. And now before we start moving stuff from side to side, Taylor, what can I do on the left?
You can combine like terms, so we get 7x
So 4x and 3x is, yep, 7x.
minus 3.
Negative 6 plus 3 is minus 3. Now we can start moving stuff from side to side. Brian, what would I do next?
You would add 3 to the side.
Okay, so we could add 3 to both sides, and that would give me
Plus 5.
plus 5. Okay, my next step, how about Josh?
Subtract 5x from the side.
What's that going to give me on the left?
2x.
2x equals 5. And lastly, divide by 2. Okay, so x equals 5/2. Could there be another solution to this equation? Yep. No. Nope, it's a linear equation. It can only cross the x-axis at most one time. Lines only cross one time unless it's horizontal. Then it might not cross the x-axis. Okay, any questions on that? Okay, absolute value equation. Okay, when you have an absolute value equation, the idea is you take it and you split it into 2 separate problems, and you solve each one. But before you can split it, you have to isolate the absolute value expression. So what I mean by that is, say you had this. Before I can split this into 2 problems, I would add 4 to both sides and make it x plus 2 equals 9. Now this is ready to split into 2 problems. Okay, so you have to isolate the absolute value expression. Nothing else can be on the outside of the bars. Okay, when you split it up, the first equation you get, it's exactly the same as the original, except you just take out the absolute value bars. That's it. So if we were doing this one, it would be x plus 2 equals 9. That would be your first equation. Okay, the second equation, again, same equation as the original, except you take out the bars, just like we did, but we have one extra thing we have to do. Change the sign of the number on the other side. Or another way to say that is negate. Okay, so the second equation, it's the same as the original. Take out the bars and change the sign of the number on the other side. Okay, so my first equation here would be x plus 2 equals 9, and we would solve. Using the directions in the second step, anybody think they could tell me what the second equation would be? Yeah?
X plus 2 equals -9.
Yeah. X plus 2 equals -9. You'd solve each equation, and you'd get two answers. Okay? The two answers should make sense visually because an absolute value is a V shape. It's not a parabola. It's two very straight sides, and they come to a point and make a V. If you think of a V, how many times can it cross the x-axis at most? Twice. And if you solve it, this will tell you the 2 points where the V crosses. It will go through one. And remember, when you solve it, the two answers are connected with and. So you get x equals 7 and x equals -11. Okay, so we put the word and between them. Okay, let's try this one. Here the absolute value has already been isolated for you. The only thing on the left-hand side is absolute value. There's nothing else on the outside of it. So let's split it into two problems. Sam, could you tell me one of the equations that it's going to split into?
2x plus 3 equals 5.
Okay, so 2x plus 3 equals 5. And how about Orlando, my second equation?
2x plus 3 equals -5.
Yes, 2x plus 3 equals -5. Okay, now solve each one. So subtract 3 from both sides. 5 minus 3 gives us 2. Okay, x equals 1. And on the other side, subtract 3. -5 minus 3 is -8. And divide by 2. And we get x equals -4. Okay, the only way an absolute value equation would have only one answer is if it was equal to what number? Yep, Carla? 0. If this was 2x plus 3, absolute value of 2x plus 3 equals 0, well, one equation would be 2x plus 3 equals 0, and the other equation would be 2x plus 3 equals -0. Okay, but that's the same thing. Okay, what if, okay, I didn't have one like this, but what if I did this? Absolute value of 3x plus 4 equals -5. Thoughts about that problem? What would you do? Yeah.
One of your equations would be 3x plus 4 equals -5.
Okay. And what about the other equation?
It would be 3x plus 4 equals 5.
Okay, let's solve it. I don't know if the numbers are going to come out particularly nice because I didn't check it, but let's solve it and see what happens. So we subtract 4 from each side and we get 3x equals -9. Or x equals -3. And if we do it on the other side, we get 3x equals 1, or x equals 1/3. Let's go back and check that. Okay, so if we plug in -3, Michael, what's 3 times -3?
-9,
And then -9 plus 4?
-5,
And then what's the absolute value of what you just said?
5.
5. Did that check?
No.
No. Didn't work. And if we try 1/3, 3 times 1/3 is 1. 1 plus 4 is 5. And then the absolute value of 5 is 5. That didn't work. So what happened? Did we make a mistake? How come both? We did everything right, but why didn't the answers work, Shan?
Because the equation is wrong, I can't have a negative be equal to an absolute value.
Right, the whole problem is right there. You're saying that the absolute value of something equals a negative number. That's impossible. Okay, so some people do exactly this on a test. They just split it, they write those two answers, and they think they're good. But if you have an absolute value equal to a negative, right away you should be writing no solution. Okay, there is no solution to this. Okay, how about if I did, let's say, that. Okay, would you write no solution right away here? Why not, Nick? What's going to happen this time?
If the number that comes out of the absolute value is less than 5, it could be a negative.
So what would be your first step here if you were going to solve that?
Move the add 5 to both sides.
Right. And then when you add the 5 to both sides, now you have a problem that's doable, okay, because it's not negative anymore. So if you see a negative like this, don't just write no solution. Check if there's some arithmetic you need to do to possibly make that a positive number, okay, by isolating the absolute value. Okay, next kind of problem we're going to look at, very common kind of problem from Algebra 1 is a mixture problem. Okay. How many people remember doing those from Algebra 1? You mix like 2 different kinds of stuff and then you want to get a certain amount as your final answer? Other people? So it generally requires 2 equations. And one equation is going to be for the amount of stuff you want to get. Okay, let's say I had a solution of, maybe from chemistry, you're using like rubbing alcohol to disinfect something. And maybe you have a certain amount of alcohol that's at 10% strength. And then you've got another amount that's, say, 16% strength. Well, and you want to mix the two together to get a concentration of 11% strength. And you want to have 50 gallons of it. So the idea is how much of one and how much of the other do you mix to get exactly 50 gallons of 11% strength. Okay? So the 50 gallons part, that would have to do with the total amount. And then the strength part, 11%, okay, that I gave, that's the concentration of it. So the second equation is your concentration equation. And it's usually a concentration times an amount, some amount of the first one, plus a concentration times some amount of the second thing we're going to mix. And that's equal to the concentration we want to get in the end, and the total amount of stuff we want to have in the end. Now, a shortcut to this is to think of the substitution in your head. Okay, if you can do the substitution in your head, you won't really need 2 equations. You can do it with 1. Okay, but I'll set it up as 2, and I'll do the substitution out so you can see it. And keep in mind, most of our mixture problems are going to have 2 things we're mixing. We're not going to get into mixing more than 2. Okay, so the 2 solutions we have are a 10% solution. We'll call that solution A. And we have a 25% solution, solution B. Okay, the percentages are the strengths of it, how strong these solutions are. What I want to do is mix some of solution A, some of solution B, to get a total of 15 liters. And I want the strength of the solution to be a 12%. Based on the strength of it, do you think I'm going to need more of solution A or more of solution B? And this is just kind of a common sense check. So when you get your answer, you know, it kind of makes sense.
You want more solution A.
Yeah. The concentration we want in the end is closer to 10, it's 12%. That's closer to solution A. So we're just going to need a little bit of B, mostly A. Okay, so the question is, how many liters of solution A and how many liters of solution B. Okay, even though it's going to be a word problem, it's still going to be a basic linear equation. There's going to be one answer for A and one answer for B. Okay, let's start off with our equation for the amount. How about, Andrew, can you give me the equation for the total amount of stuff I'm going to have in the end?
Sure.
And you can let A and B, you can use those as your
Oh, okay,
variables.
yeah, so
Yeah.
then, A plus B equals 15 liters.
Perfect. A plus B equals 15 liters. That's the equation that represents the total amount of stuff. Now we need the one for the concentration. Okay. And when we do the concentration, we always want to write it as a decimal. Okay, so Justin, what's my concentration of solution A?
0.1.
Yep, 0.1. So we're going to need 0.1 times the amount of that solution, which is A, plus, Sam, what's the concentration of B?
0.25.
0.25. And how much of that one? We're going to use B. And now we need the total. Okay. How about Brian? What's the concentration I want to get when I'm all done?
0.12.
So 0.12. And how much do I want to have?
15 liters.
15 liters. Okay, so this is the equation. If this was like the example I had given you with like the rubbing alcohol, this second equation actually tells you how much alcohol, like pure alcohol from solution A, because it's only a 10% strength, how much pure alcohol from solution B, and then how much pure alcohol we're going to have when we're done. Because it's 15 liters, but only 12% of it is the strength. All right, so let's simplify the second equation a little bit. 0.1A plus 0.25B. And the right-hand side, we can just do that out. So 0.12 times 15, that's 1.8. So now we know out of our 15 liters, 1.8 of it is pure 100%, whatever the solution is. All right, so there's our second equation. But how am I going to use the first equation? What do I have to do here? Yeah,
You solve for one of the variables.
sure. Let's solve for A. What would A equal? Carly?
15 minus B.
15 minus B. And this is the part where you probably could have done the substitution in your head. Because if you're going to use, let's say, B liters of one solution, then you're going to use 15 minus B of the other. Okay. So now just do the substitution. So 0.1 times 15 minus B plus 0.25B equals 1.8. Distribute out. 0.1 times 15, that's like dividing by 10. So it's 1.5 minus 0.1B plus 0.25B equals 1.8. Now we just have a basic linear equation. All right, so we've got negative 0.1 plus 0.25. It's 0.15B. I'm going to subtract 1.5, bring that to the other side. 1.8 minus 1.5 leaves me with how much? Yep.
0.3.
0.3. Okay, divide by 0.15. Divide by 0.15. And how many times does 0.15 go into 0.3? Or you can think of it as 30 divided by 15. Same.
Isn't it 1.5? Oh, no.
So yeah, you subtract your 1.5. It's Subtract your 1.5. That's how I got the 0.3. And then I did 0.25 minus 0.1. Okay, so what do we get?
2.
2 meters. And let's see if that makes sense. We said we would want a small amount of the solution B. Okay, so how much of solution A do we need? We know our total. We know how much of B. Orlando?
13.
13. Yep. Okay, so that's a basic mixture problem. That's pretty much how you set them all up. Okay. Any questions on mixture problems? Okay. All right, quadratic equations. So quadratic equations have the form on the board. Okay, we've written that before, ax squared plus bx plus c. A, b, and c can be any real number you want, except a cannot be 0. The reason we've already talked about earlier, the idea is that if you let a be 0, it wipes out the quadratic term. And then you'd be down to a linear equation. But b could be 0 and c could be 0. In fact, when b is 0, c is 0, and a is 1, that's the simplest quadratic equation you can have. X squared equals 0. Okay, so there's a few different ways we can solve the quadratic equation. We can factor. Okay, we're going to get to it in a second, but what's another way to solve besides factoring? We looked at this way earlier when we were talking about shifts and transformations of parabolas. We had to do this method. Yeah.
Well, did we use the discriminant?
So the discriminant is good to tell you how many solutions you're going to have, but if you want to take an equation like x squared plus 5x plus 7, and get it in the form where we can recognize the horizontal shift, the stretch, there's a method we use to do that.
Quadratic formula.
No, we didn't use the quadratic formula. Because the quadratic formula is basically just going to give us x equals and then an answer. What we're looking to get is something like this. Then we could see, oh, it's been shifted down 4 and it's been shifted left 3. But we can't see it when it's written like that. Does anyone remember how you take an equation like that and change it to something like that? Yeah? That's part of the method. You end up factoring as like maybe the second or third step. Or completing the square. Okay, completing the square. So that's the method that you would use. All right, so factoring, completing the square, and quadratic formula we don't know yet. We're gonna derive that in a little bit. Okay, let's try this one. Since the only method that we know right now, because I haven't taught you the quadratic formula yet, pretend you don't know that. You could try completing the square. Completing the square will always work. It just might not be the fastest way to do it. What's the fastest way to solve a quadratic if it works? Out of the 3 methods that I listed, Brian?
Completing the square.
Completing the square is the one that will always work, but it could be a waste of time if another method works. Completing the square can take a long time. So can quadratic formula.
Factoring?
Factoring is always the fastest way to solve a quadratic. Okay? Of this type. Okay, so let's see if we can factor it. 2x would be my first term in the first binomial. What about my first term in the second binomial? Yep.
X.
It would have to be x. This one's not going to be bad if it factors because you don't have many choices. It has to be 2x and x. What about my signs? I have a positive middle and a negative constant. Brandon? Well, if you do minus minus, minus times minus to get the last term would give me a positive. One's going to be plus, one's going to be minus, and it does make a difference which one we put where. Let's just try it that way, and if it doesn't work, we'll switch it. Okay, two numbers that multiply to give me 3. Michael?
3 and 1.
3 and 1. Okay. Which one do you want to put in the first step, 1 or 3?
3.
Okay, let's check and see if that works. So if we do it out, we're going to get 2x minus 3x. 2x minus 3x, does that give me what I wanted in the middle? No. It's not even the right sign, so what should we do with the 3 and the 1? Yeah, flip them.
Maybe change the sign.
We might have to change the signs. Let's check. 2x times 3 is 6x. Negative 1 times x is negative x. 6x take away 1x. Is that what I wanted?
Mm-hmm.
Yeah, then I just factored it. I don't have to check the first and the last term because I picked those. I know those are going to come out right. It was just the middle. Okay, and Justin, what do I do with each of these factors now? 2x minus 1, and then x plus 3 multiplied together equals 0. What's my next step? Yeah, set each factor equal to 0. Okay, so we're going to multiply two things together and get 0. That means either the first one is 0, or the second one is 0. So we're going to get two answers. X equals a half, and x equals negative 3. Okay, any questions on solving a quadratic by factoring? All right. So if you can't factor it, you can always complete the square. But there's a formula that we can use that most people tend to do it that way instead of completing the square, and that's the quadratic formula. Okay, so what we're going to do is we're going to figure out what the quadratic formula is. Okay, has anybody ever done that before? Instead of just someone putting it on the board for you, you actually see where does the formula come from. All right. To get the formula, all we have to do is solve this equation. How do you solve it? We'll complete the square. It's just going to be completing the square, and it's all variables. Okay, we're not going to have any numbers. First thing you have to do when you complete the square is the constant has to be where? Well, it's on the same side right now, but it actually has to move somewhere else. Where does the constant have to go? How about Tahina? Well, where can it go? It's on the left, so put it on the right. So we're going to, how would you get it on the right? Subtract it. Okay, what else when you complete the square? The coefficient of x squared has to be what? Can't be a. Has to be, yeah? Has to be 1. How would you make that a 1?
Divided by 8.
Yes. So to divide everything by a. So now those cancel out. X squared plus b over ax. Leave a little bit of space because we're going to complete the square. Equals negative c divided by a. Now we have to add something to both sides to complete the square. Does anybody remember what you do? It's something with the b over a, two things. You do one thing, and then you do one other thing. Yeah?
You divide it by 2.
Okay, so divide it by 2, which is the same as multiplying it by a half. So that's half of it. b over 2a, yep. Yep.
And you square it?
And you square it. That's what you need to add to both sides. b over 2a squared, and and b over 2a squared. Okay, if you've added something nice, the left-hand side should factor pretty easily, and this one will. It'll factor as x plus b over 2a. If you FOIL that out, you'll get exactly what's on the left-hand side. And that's equal to negative c divided by a. Let's do out the squared fraction. Square the numerator. How about, Taylor? What do you get when you square the numerator?
B squared.
Yeah, just b squared. And when you square the denominator, you get 4a squared. Okay, any question on that so far? All right, next thing we should do is try to get a common denominator. Okay, on the right-hand side, what's the common denominator between a and 4a squared? Yep.
A? Or,
We need more than a to make
4A
it.
cubed?
A little simpler than that, just 4a squared. Okay, so this denominator on the right, we don't have to change. What would you multiply top and bottom by?
4A.
4a. Okay, so keep the left-hand side the same for now. And what I'm going to do is I'm going to switch the order of what's on the left and the right, and hopefully you'll see why in a second. I'm going to have b squared. Common denominator is 4a squared. And what did we multiply top and bottom by?
4A.
4a. So I have times 4a times 4a. Well, that's 4 times a times c, and it's negative. So now my numerator is b squared minus 4ac divided by 4a squared. Okay, our goal is to get x alone. Okay, so the next thing we want to do is get rid of these parentheses on the left. How do I get rid of this exponent of 2? Yep.
Square root both sides.
Square root both sides. This should really be starting to look like your quadratic formula. So we're going to have x plus b over 2a. The numerator you're not going to be able to do anything with. It's just going to be the square root of b squared minus 4ac. But what's the square root of 4a squared? Yeah, 2a. 2a times 2a is 4a squared. And now we pretty much have the formula. We just have to move b over 2a to the other side by subtracting it. So when I subtract b over 2a, it already has a common denominator. So I can just throw it right in the numerator. So it's going to be subtracted and become a negative b when we subtract it. So it's negative b. And remember, once we take that square root, there's really two. There's a positive and a negative. Plus or minus b squared minus 4ac. And it had a denominator of 2a, so does the other side. It all has a common denominator. And that's the quadratic formula. It's not too bad to divide. It's a basic completing the square. What gets some people confused is it's all variables. There's no numbers. But I did nothing more than complete the square there. That's all I did. Okay, now that we have that formula, we're not going to go through deriving it again. We're just going to use it. Okay, earlier somebody mentioned the part under the root. That is the discriminant, b squared minus 4ac. We use the discriminant to determine how many solutions it has. Okay, and we went through that earlier. Okay, if you want to use the quadratic formula, it has to be in this form. You have to have an equation equal to 0. The coefficient of x squared is a. Coefficient of x is b. Your constant is c. Okay, so let's solve this one. I don't think it factors. So if you tried to factor it, yeah, it's not going to work. You could complete the square. That would work fine. Or we could use the quadratic formula. Okay, so that's A, that's B, and my constant is C. Does everybody have the quadratic formula discriminant part? No, okay. All right, so let's solve this. So we're going to have negative B plus or minus, and can somebody else fill in my discriminant for me? You don't have to do out all the arithmetic. Just tell me, what times what minus what. Yeah.
2 squared
Okay, so B squared, that's going to be 2 squared.
minus 4
Okay.
times 2
Yep.
times negative 1.
Okay. And all of that is going to be divided by what? Orlando? 2a, which in this case is 2 times 2. Okay, so we're going to get negative 2 plus or minus the square root of, we have minus a minus. Okay, so that's going to turn into a positive. So we're going to have 4 plus 4 times 2 times 1 gives me 8, all divided by 4. So it's the square root of 12 for the discriminant. How does the square root of 12 simplify? Yeah.
2 square roots of 3.
Okay, 2 square roots of 3. And I simplified it because what's going to happen now? How about Silvio? What can I do there now?
You can factor out negative 2 from 1.
Yeah, we can factor 2 out from everything. Not what's under the root, just everything that's outside it. So 2 goes into 4 how many times? Twice, and then into 2. Once, and then into 2 once. Okay, so what we end up with, our final answer is negative 1 plus or minus root 3 divided by 2. Okay, if they ask you for the quadratic formula, generally don't bother with the decimal. Just leave it as an exact. Okay, any question on that? All right, last one. I don't want to solve the whole thing. I just want to set it up so that I could use the formula. What do I have to do with this equation to get it in the right setup to then plug in A, B, and C? What do I have to do first? Josh?
You could put negative x squared in front of negative 4.3, or negative x squared plus 3.
So, okay, negative x squared, yeah.
Plus 3x.
And that's equal to?
If you, it's equal to 1, but you subtract 1 from both sides.
Yeah,
So it's minus 1 equals 0.
perfect. Now he's got it set up where, what's A in this case though?
Negative 1.
Yeah, A would be negative 1, B would be 3, C would be negative 1. Since we haven't studied complex and imaginary numbers yet, it might be worth just checking B squared minus 4 times A times C in your head. If it comes out negative, it's going to be imaginary. We can't solve it yet. Okay. But in this section, they're probably going to make it so it comes out real. Any questions where you go from there? All right. So that's a quick summary of quadratic equations from Algebra 1 and 2. Okay, on page 88, all I want you to do is 35 to 39. That's mostly on the calculator. Find a complete graph, break-even point problem. Then on 96, this is solving linear and quadratic and absolute value equations. It's 1 through 4, 9, 11, 13, 16, 19, and then 24 to 26, 36 to 38, 52 to 54, and 58.